In this presentation, we're going to talk about empirical rule. We had two branches in statistics. One of them was descriptive statistics. Descriptive statistics is a term given to analysis of data using certain formulas, definitions, methods that ultimately helps us to describe or summarize data in a meaningful way. The type of descriptive statistics are central tendency and variability or dispersion. The central tendencies include mean, mode, and median. And the variability or dispersion, it shows how data elements vary or disperse with respect to the sample mean. And these measures include variance and standard deviation. Now let's take a look at bell-shaped distribution. A data set has approximately bell-shaped distribution when its mean, mode, and median are equal or approximately equal. This is a typical bell-shaped looking distribution. Once again, this happens when mean, mode, and median are the same. Now we can take a look at empirical rule. Empirical rule is used to provide an estimate on what percentage of values in a data set are within a range of the mean. There are three properties on empirical rule. About 68% of all values fall within one standard deviation of the mean. In mathematical notation, that would be x bar plus or minus one standard deviation. The second property of empirical rule is the 95% range. About 95% of all values fall within two standard deviations of the mean. So that would be x bar plus or minus 2 times s. Empirical rule also says about 99.7% of all values fall within three standard deviations of the mean. That is x bar plus or minus 3 times s. On a bell-shaped distribution, the 68% will be within one standard deviation of the mean, and the 95% will be within two standard deviations of the mean. The usual range. Usual range is another name for the 95% range. Once the data has a bell-shaped distribution, and that happens when mean, mode, median are either the same or approximately equal. The usual and unusual values. The usual values fall within the usual range, and unusual values fall outside the usual range. Remember, the usual range is another name for 95% range. A 95% range is mean plus or minus 2 times standard deviation. In this example, we're supposed to find the 68% and 95% ranges of bell-shaped distribution with the mean of 74 and a standard deviation of 6.5. Using empirical rule, the 68% range will be x bar plus or minus 1 standard deviation. Plug in the values, and the 68% range will be 67.5 to 80.5. And for 95% range, we compute x bar plus or minus 2 times standard deviation. Once again, we plug in the values, we do the calculation, and that tells us about 95% of the data fall within 61 and 87. In this example, we're given the salaries of 800 randomly selected nurses that has a bell-shaped distribution with the mean of 5,800 and a standard deviation of 250. We want to find the usual range for the salaries of these nurses. We want to find the percentage of these nurses that have a salary which is considered unusually high. And we also want to find how many of these nurses have a salary that is considered unusually high. We're told the data distribution is bell-shaped, so we can use the empirical rule. The usual range, which is the same as the 95% range, can be found by computing x bar plus or minus 2 times s. We plug in the values. So now we know about 95% of salaries of these nurses fall within $5,300 and $6,300. For the unusual salaries, we know that 95% are considered usual. So that leaves us with 5% unusual. From those 5%, 2.5% will be unusually high, and 2.5% will be unusually low salaries. So for the unusually high salaries will be 2.5%. For the number of unusual high salaries, we simply compute 2.5% of the sample size, which is in this case 800. So we multiply 2.5% times 800, and the answer is 20. So about 20 of these nurses have unusually high salaries. And if we use the symmetry, then about 20 of them also have unusually low salaries. I hope this presentation helped you understand the empirical rule and how to use it in application problems.